Hi everyone, my name is AJ Alvero and I will be presenting work with Stephanie Tena-Meza. As we all know, gender and racial gaps in CS education are pervasive, and these gaps partly explain gaps in lucrative careers in CS, as well as missing voices in important design choices with CS. So therefore, understanding education enrollment data with CS is extremely important. In CS education, enrollment data is collected by nonprofits like Code.org and state education agencies. And this data is then used to inform various decision-making processes in and out of education. This work was also inspired by a historical autoethnography from Stephanie, and we unearthed a discrepancy in publicly available CS enrollment data from our schools. So to quickly go over existing systems and methods, in general, the narrative is often that CS enrollment data is positive, more students have access, it's more popular than ever, more students are participating, and states are starting to adopt uniform standards in CS to help with teacher training and recruitment. And for example, California just adopted its own CS standards. And finally, anthropology of policy or ethnography of policy is a growing area where the stories and experiences of an individual are the center of analysis with respect to a certain policy. So to go over the issues we identify with CS enrollment data, first is the need for uniform standards. So for example, Code.org claims that 42 million K-12 students in the US use their website, but only 2 million users demonstrate basic proficiency. Lots of groups and entities collect this data and promote CS, but the lack of uniform standards creates data that can tell multiple stories at the same time. So CS education is simultaneously popular, yet there's little proficiency. And this dissonance creates a lot of problems. And education systems might be incentivized to target popularity when counting CS students, not necessarily proficiency. The second issue we identify is what we call workers versus thinkers. And where we identify that current CS enrollment statistics and data mask emerging patterns of student tracking in CS education. There's lots of ethno-racial and socioeconomic realities baked into academic tracking, such as white, wealthier students having access to the more prestigious, more resourced academic tracks, whereas racialized, less wealthy students are tracked into lower resource, less prestigious academic tracks. In CS education, this looks like classes where the goal is to learn the basics of operating a computer, like typing for work, and higher tracks teaching complex but valuable computer skills and knowledge for thinking or coding. Third issue we identify is the importance of personal narratives. Personal narratives from students provide unique experiences, perspectives, and insights that basic forms of quantitative data cannot. Types of CS learning environments encountered by students can be described and unearthed through personal narratives, and they can contextualize the who, what, when, where, why of students learning CS. And now I'm going to pass it over to Stephanie.
So now I'll transition to talk about my autoethnography and data snapshots in detail. These two methods demonstrate a need for uniform standards and the importance of personal narratives to inform data. My autoethnography is situated in Salinas, California. Salinas is a rural community located in Northern California and is approximately 70 miles away from the Silicon Valley. It is nicknamed the salad bowl of the world because, as the name suggests, it produces crops for the world, such as lettuce and strawberries, and it is also home to a multi-billion-dollar agricultural industry. So now I will share the journey that I needed to take in order to learn computer science. In 2014, when I was a 7th grader in middle school, I participated in a community coding club named Quarter Dojo. Quarter Dojo sparked my interest in coding, and I would attend it during the weekends to learn more about it. In fact, I frequently went to Quarter Dojo because my middle school at the time didn't offer coding classes or clubs. So it was through my participation in that program that I was able to learn about coding and technology. Then, when I entered high school in 2016, there was a similar story. So I found myself being one of the few that had an interest in computer science, coding, and STEM, and that I needed to look outside of my school and even my community to have access to computer science. So in the summer of 2016, I attended a coding camp in Los Angeles named Code with Classy. During this coding camp, I was learning to code in multiple languages and getting exposure to computer science too. So this was something that I consistently did throughout my high school experience. In 2017, I participated in AI for All, a summer program located in Stanford University to get access and exposure to artificial intelligence. Later in 2018, I participated in a research fellowship to learn more about the intersection of computer science and social good. Computer science resources and opportunities are still not readily available in my community, so I took the initiative to create multiple computer science clubs and STEM opportunities in my middle school and high school to continue learning about this field and also share my passion with others in my community. The quotes on the screen reveal that computer science resources were limited in my community and challenging to get exposure to. One of the quotes here details that if computer science opportunities existed in our middle school, students would take these opportunities. At another point in my autoethnography, I revealed that the first time I felt a sense of community was in a coding camp I participated in. My lived experiences show the limited computer science opportunities that existed in my middle school. However, data presented by DataQuest, the California Department of Education's web-based data, paints a different picture about my community, particularly my middle school. It paints a picture that dismisses my lived experiences and challenging journey to get exposure and access to computer science. In my 7th grade year, that's 2014 to 2015, my middle school reported that 34% of my peers were enrolled in a pure computer science class. In that same year, it was also reported that approximately 40% of my peers were enrolled in all types of CS course offerings. I also want to note that most of the middle schools in this list also serve predominantly working class Latinx communities. Furthermore, we suspect similar issues with the data from those middle schools. In my 8th grade year, 2015 to 2016, it was reported that only 3% of my peers were enrolled in all types of CS courses. So that's a big drop from 40% in the previous year. Additionally, in that same year, my middle school did not report students enrolled in pure computer science courses, but rather wealthier and predominantly white communities didn't show enrollment for students in pure computer science classes. These data snapshots show an influx in CS education standards and/or definitions. Our work demonstrates a need for elevating stories of people from marginalized communities and backgrounds. Lastly, our mechanism design suggestions include to create uniform standards for CS education and to ensure that students, especially in today's day and age, have true computer science education. Thank you.